Hey everybody! Today we're going to talk about similar figures. We're starting on page 4 in your packet, so you're going to want to grab that and follow along taking these notes down in your packet. Yesterday we talked about ratio and proportion. Today we're going to take it a step further and talk about figures that are similar. So first of all, this right here is the symbol for similar. It's similar to what we did with congruent triangles, but with congruent triangles, not only are they the same shape and size, or not only are they the same shape, but they're also the same size. With similar, they're not necessarily the same size. They have the same size angles, but we'll talk about that. So if you look at these first two triangles, they are similar, whereas the other two are not. All right, you can see that they have a different shape. So two polygons are similar only if their corresponding angles are congruent. So all of their angles are going to be congruent, and their corresponding side lengths are proportional. Now, that does not mean that they're the same length, because clearly this figure is not the same size as this figure. So let's see how we can work with these. So first of all, if you notice the markings, you have two right angles, so those are both 90 degrees. And then if you notice here, we have one arc, and then we have two to match, so those angles are the same. Now, and it tells you over here what angles match. Now, as far as your sides being proportional, basically they simplified to give you the same ratio. So let's take a look at what they have right here. So it says side AB, which if we look on the picture, side AB matches side EF. Now, it's not just because they're both the top. It all depends on how it's set up, how it's drawn. But one thing I like to do is if I'm looking at side AB, it's the first two letters, so it matches the first two letters over here, EF. All right, so let's figure out what the similarity ratio is. So side length AB is 6 and EF is 12. So 6 over 12 simplifies to 1/2. Basically, when you're dealing with similar figures, every single fraction is going to simplify to that ratio, 1 over 2. So for BC, if we find that on here, 5.4 over FG, 10.8. That simplifies to 1/2. CD is 4 over 8. That simplifies to 1/2. DA is 5, HE is 10. That simplifies to 1/2. Okay, since they all simplify to the same thing and all their angles are congruent, then these two are similar. And here's your similarity statement right here. ABCD is similar to EFGH. And your similarity ratio in this case is 1/2. And it doesn't matter what figure you're looking at first, but we'll look at an example with that in a minute. Okay, so identify the pairs of congruent angles and corresponding sides. All right, so first of all, I see that this is 63 and this is 63. I see that angle N and Q are both 90. Well, if you want to figure out what that missing angle is, you could subtract. But because these two are the same, we know that the third angle is going to be the same as well. So let's write down what angles are the same. Why don't we just go it alphabetically? Angle M, angle N, angle P. So I'm just looking at the three angles here. So M would match angle T over here. And they're congruent because they're the same size. Angle N is my right angle. That's congruent to angle Q. And angle P is 63, and so is angle R. All right. Now it says to identify the pairs of congruent angles, which we did, and corresponding sides. All right. So I'm actually going to write my similarity statement. It doesn't ask for it, but it kind of helps me to keep myself organized. So triangle MNP is similar to triangle TQR. Again, it's got to be the matching or the corresponding angles have to match up. So now if I'm looking at side MN, since that's the first two, it's going to correspond to TQ. And if I'm setting that up, MN is 2, TQ is 1, 2 over 1. There's my similarity ratio. All right. That's also going to be equal to, well, let's do the next two letters. Let's do NP. And side NP would match side QR, right? Again, look at second, third letter over here. All right. And lastly, side MP would match side TR. And again, our similarity ratio is going to end up being 2 to 1. Now, it gave us NP was 1. It gave us MP is 2.2 over 1.1. If you divide those, you're going to get 2, or 2 over 1. So this would have to be 0.5 in order to be 2 over 1. But anyway, 2 over 1 is going to be your similarity ratio. It didn't ask for it, but I thought I'd point that out. Okay, the next two deal with the question or the picture at the bottom. So state the similarity ratio of ABC to DEF. Okay, so order does matter. They're both equilateral triangles. So if I'm doing ABC first, if I'm doing ABC first, my side lengths are 3. For DEF, it's 6. So 3 to 6 would simplify to 1/2. Or 1 to 2. You could write it using the colon. All right, now it says what's the similarity ratio from DEF to ABC. So DEF would be 6 to 3, or 6 over 3, which simplifies to 2 over 1. So look at the difference between those. They're not the same. The order does matter. So basically what it's saying is every side here is doubled to get this one. Okay, go to page 5. Let's do some more practice with this. All right. Determine if triangle JLM is similar to triangle SPN. If so, write a similarity ratio and a similarity statement. They already have the statement, so we can just look at the ratio. Okay, so first of all, just grab any, I look at my first triangle. Side JL is 75. And again, we've got JL here, so it would have to match SP, which they're both the hypotenuse, so that makes sense. So 75 over 30. All right, if you type that into your calculator, mine might take a minute. Okay, we're not getting into it. 75 over 30, I'll save you the time. If you put it in your calculator, you get 2.5, math, enter, 5/2. All right, so again, calculator, math, enter, to get your fraction. All right, so let's make sure that all three do this. So now if I look at JM, that's 45. JM is going to match first last. So first last SN, which is 18. Might as well do the last one while we're at it. 60 would match 24. Now if you divide all three of these, I get 5 over 2 for all of them. So that means that they are similar. Okay, they have two congruent angles, which we'll talk about as one of the ways of proving that they're similar, but all their sides are proportional. So they are similar. Oh my gosh. So yes, they're proportional. Triangle, we already have the statement, but we'll write it again. JLM is similar to triangle SPN. And the last part of this, the similarity ratio, is 5:2. All right, and that's all there is to it. You're really just matching sides. All right, last one. Feel free to pause it if you want to try this on your own. Determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. Well, the sides, I mean, from what I can see, 10/5 is the same as 10/5, but you got to look at the angles. All right, if this is 36, if these are both the same, their base angles are the same. So let's do 180 minus 36. That gives us 144 between the two of those. So that means that this angle is 72 degrees and this angle is 72 degrees. Well, the same thing's true over here. If you have two congruent sides, you have your isosceles triangle. So if this is 62, this is 62. I can already tell, because you have 62, 62, and then 72, 72. These are not similar triangles because the angles are not the same. So we can stop right there. No, the angles are not congruent. Okay. All right, this one tells us that ABCD is similar to EFGH, so we find the value of x. Well, they gave us side AB. AB matches EF. So I'm going to set up a proportion like we did yesterday. 4 over x plus 3 equals. Now, since I did the smaller triangle on the top, I need to do that same thing in the other half of the proportion. So 3 over 2x minus 4. And you know what to do. We're going to cross multiply. So we have 4 times 2x minus 4, and that's equal to 3 times x plus 3. Now, if you want, you don't have to show that step I just did. You could automatically distribute, but I just wanted to show you what was happening. So 4 times 2x is 8x. 4 times negative 4 is negative 16. 3 times x is 3x. And 3 times 3 is 9. All right, now if you have a hard time solving equations, just draw the line down. Move your x's first. I'm going to bring the 3x over, so I'm going to subtract it on both sides. 8x minus 3x is 5x minus 16. If you guys are having trouble solving equations or any of these pieces from algebra, you're welcome to stop by the math lab anytime. We're happy to help. Sometimes it just takes a couple practice problems and then you got it. So we have 5x equals 25. Divide by 5. X equals 5. And it did say to find the value of x, so we're done. If it wanted you to find each side, you would substitute that in. Okay, last example. A boxcar has the dimensions shown. So we have 9 feet and 36.25 feet. A model is 1.25 inches wide. Find the length. Well, again, you want to be consistent. All right, so 9 is the height of the boxcar, or the width, I guess they're calling it. So 9 in the other diagram in the model would match the 1.25. So there's my first fraction. And now the 36.25, that's part of the original boxcar, which we put on top over here. So we did boxcar over the model. So I got to do 36.25 over the model here. Cross multiply. Once you get the proportion set up, it's easy. So 9x equals 1.25 times 36.25. So we get 45.3125. And then divide by 9. Now notice it said to round to the nearest inch. Don't round right here. Round at the end. Sometimes it makes a difference. And we get 5, and it's inches because you're looking at the model. Okay, so that's similar figures. Your homework is just on page 6. You're going to want to set up a proportion for the first one. The second one is review from 7-1. So take a look at your notes from 7-1 if you need to. And then the rest of this is from today. All right, should be pretty quick and easy overall. We'll get some more practice with it tomorrow. I will be checking pages 1 through 6 at the start of class tomorrow, so make sure they're all done. If you have questions, stop by the Math Lab. Have a great day.